Hi, today we're going to talk about soluble ions and solubility. Salts, such as sodium chloride, naturally occur in the seas and underground deposits. Salts are primarily harvested from the sea, natural brines and rock salt deposits. On the other hand, salts can be prepared in laboratory. To determine which method to use in salt preparation, we have to know the properties, whether the salts are soluble or insoluble. Here, let's go through the solubility of some common salts in water. Firstly, potassium, sodium, and ammonium salts are soluble. Potassium chloride plays a vital role in the transmission of nerve impulses in the human body. It is also a common source of potassium in agriculture and widely used in fertilizers. Potassium iodide is added as a nutritional supplement in tablet salt, as well as animal feeds. Sodium chloride is abundant in seawater. It is an essential ionic compound with diverse functions, such as nerve conduction and muscle contraction in our body. Some common ammonium salts are ammonium carbonate, which has been used as leavening agent in the old days, and ammonium nitrate, which can be used in production of fertilizers and explosives. Besides, the acidifying properties of ammonium chloride account for its importance in industries as well as in the human body, such as acting as an acidifier in food preparation and regulating urine pH. Nitrates are soluble. Sodium nitrate is a preservative generally used in processed meat, such as bacon and sausage. Silver nitrate is an anti-infective chemical used as an astringent and antiseptic agent. Hydrogen carbonates are soluble. Sodium hydrogen carbonate and potassium hydrogen carbonate can be used as antacids, which is medicine to treat indigestion by neutralizing the acid in the stomach. Halides include chloride, bromide, and iodide, are soluble except for silver and lead. As silver halides are insoluble, it can be used to test for the presence of halides and distinguish between different halides. Silver chloride, silver bromide, and silver iodide precipitations all have distinguished colors and properties. Sulfates are soluble except lead to sulfate, barium sulfate, and calcium sulfate, which is only sparingly soluble. Copper sulfate dissolves in water and forms a blue solution. Barium sulfate is insoluble and radio-opaque, which means that X-rays cannot pass through it, making it possible to act as a radiographic contrast agent in X-ray examinations of gastrointestinal tracts. Carbonates are insoluble, except for potassium, sodium, and ammonium carbonates. As stated at the beginning that all potassium, sodium, and ammonium salts are soluble. Calcium carbonate, as an insoluble salt, is the predominant component of limestone, seashells, eggshells, etc. So now, let's look at how we prepare soluble and insoluble salts respectively. There are two main steps in preparing salts artificially, regardless of soluble or insoluble salts. The first step is to make a reaction to produce the salts of interest. The second step is to separate and purify the salt produced. To prepare soluble salt, we mix acid with metal, an insoluble base or an insoluble carbonate. In this case, filtration followed by crystallization and filtration again will be performed in the second step. Otherwise, we mix acid with an alkali or a soluble carbonate, followed by crystallization and filtration to separate and purify the products. On the other hand, if insoluble salts are to be prepared, we mix two solutions to get a precipitate in the first step. For example, barium chloride mixed with sulfuric acid, and then mix hydrochloric acid with barium sulfate precipitated. Then we do the filtration in the second step. For all these methods for preparing soluble or insoluble salts, a final step of washing and drying is required. Soluble salts dissolve in water and become soluble ions. The amounts and types of soluble ions in water have great influences in Chinese mitten crabs. Salinity is a measure for soluble salt content in water. In this section, we will discuss the roles of salinity in the life cycle of Chinese mitten crabs, as well as measures of soluble ions in water quality assessment. To talk about how salt content in water affects Chinese mitten crabs, we first refer to the life cycle and catadromous migration of Chinese mitten crabs. Chinese mitten crabs is generally considered a freshwater species, meaning that they spend all or a critical period of their lives in fresh water or brackish water. Catadromous migration, or catadromy, describes the species spending most of their lifetime in fresh water, migrate to the salt water for spawning. Chinese mitten crabs are therefore sometimes regarded as marine species. When the Chinese mitten crabs migrate downstream towards the sea, gonadal development and mating in Chinese mitten crabs are triggered by brackish water. The female crabs carry the eggs and move on down to the sea. As the larvae develop during the further migration, the tiny larvae hatch from the eggs in seawater of relatively high salinity. The larvae undergo further development, during which they migrate upstream back to the river. This catadromous nature of Chinese mitten crabs explains their sensitivity to salinity in different periods over the whole life cycle. And therefore, the salinity of water environment for Chinese mitten crabs is critical and required to change over the period of the development, from embryo to juveniles and gonadal development and reproduction. All these corresponds with their catadromous life cycle. And hence, particular attention must be paid when it comes to breeding and rearing Chinese mitten crabs from very early stages. In our Chinese mitten crabs aquaponics project, however, the Chinese mitten crabs we obtain from China would be at the early juvenile stage, which is simply reared in fresh water. If we look into the location of Yangtze Lake from the map, we can notice that it is one of the nearest lakes to the Yangtze River estuary. Its proximity to Yangtze River estuary provides the crabs the best possible migration route. That makes Yangtze Lake the ideal place in terms of geographical location for farming Chinese mitten crabs. Having known the life cycle of Chinese mitten crabs, it is conceivable that the salt content in water greatly influences their larval development, molting, and gonadal development. The soluble ions, such as nitrates, are also measured for water quality in Chinese mitten crabs aquaculture industry. The water quality of Yangtze Lake, a well-known place for Chinese mitten crabs production, is regularly monitored. The amount of different soluble ions were measured. The abnormal increase of certain soluble ions would be considered as signs for water pollution. This is the end of the video. Thank you for watching. Please give us a like and subscribe to our channel. We'll see you next time. Bye bye.